Current software testing discussions are still largely about automate or don't, what to automate, what to explore, what not to explore, what value does it add to teams. Load testing, security testing, stress testing, user acceptance testing, functional testing, API testing. And those are all important facets of software testing quality. These modes of testing have required testers to have knowledge of the web, APIs, databases, servers, and the characteristics of each of these components as they interact. Web software has required testers to learn Selenium, perhaps JavaScript, Java, Python, or other scripting languages to interact with tools to conduct tests. But the future of software goes well beyond that. The future of software is everywhere, literally everywhere. Established enterprises are working on their cloud transformations, while new companies are building and deploying in the cloud from day one. And many of the services we rely on are not built and deployed on a single cloud. Software companies, large and small, as well as traditional companies embracing their digital transformation, are seeking infinite flexibility, scalability, reliability, and security as they deliver their product across the world. What might this mean for the future of software testing? For starters, the scale and complexities of the systems we test are ever increasing. There are two things that I'm going to recommend for you today as software testers in order to approach the complexities of this new future world. First, there are multiple acceptable ways to design software called software architectures. Getting familiar with software architectures, even at a high level, will allow you to understand the strengths and weaknesses of each and where each is likely to have risks. Mark Richards does a great talk called Understanding Architecture Styles and When to Use Them, and I can't recommend a better way to get started in understanding the architecture of the software that you are working with and testing. Adding to the complexity of different architectures, there are multiple ways in which software is now deployed. What was once deployed to a single physical server or a single cloud instance is now deployed across multiple cloud providers, on virtual machines, on bare metal servers, or in some cases across any number of these runtimes. Sometimes these deployments involve working with Docker images, setting up Kubernetes clusters, and working with services from multiple other vendors. Fortunately, there are a number of resources to begin learning about containerization, orchestration, and cloud technologies. I recommend that software testers take the time to select a provider or a cloud that's of interest to them and use the free trainings offered by these providers to gain a general understanding of the services that they offer and how your company might be using those in deployment. Some of you may be wondering what I mean when I say I believe these skills are going to become the future of software and software testing. So I'd like to provide you with some examples that I've seen. So, for example, if you're working on a software application that handles sensitive data in the cloud, you may need to host some data only in some geolocations in order to meet GDPR data sovereignty regulations. These regulations require that data storage and orchestration follow access security and storage controls based on the local regulations and laws where that software is deployed. In order to meet these requirements, your application may need to be deployed in multiple clouds to meet the requirements of the servers being located where your customer data is located. How would you test a microservice architecture deployed on both Azure and AWS, along with the network complexities of perhaps needing to fail over from one cloud provider to another? These are questions that having a knowledge of systems architecture and cloud operation and deploying will help you to answer. Here's another example. During COVID, an organization had to build an application to track the vaccination status of a huge number of individuals. Like everything for COVID, it had to be done quickly. And using modern cloud technology, the organization was able to build quickly. They strung together several databases, Lambda functions, and reporting tools to accomplish their aim. But by the time they were done deploying, Nobody on the team even knew all of the components, could draw a map of the system, or could rebuild it anywhere else. How would you approach understanding and testing that system if you were hired to do this job? Questions and problems like these are the questions that I believe that software testers and quality engineers will face more frequently in the coming months and years, because the future of software is everywhere.